Next is question number 66, that is, if z is a complex number in Argand plane, then and the equation mod of z minus 3 minus 4 iota square plus modulus of z plus 2 plus 8 iota whole square is equal to lambda, where lambda belongs to n and iota is equal to root of minus 1 represents a circle, then the least value of 2 lambda should be. Now, we know that for equation of circle as z minus z1 mod whole square plus z minus z2 mod whole square equal to k, it will represent a circle if k is greater than or equal to half of mod of z1 minus z2 whole square, right? So comparing the given equation with this, we can see that lambda should be greater than or equal to half into mod of, here z1 will be equal to 3 plus 4 iota and z2 will be equal to minus 2 minus 8 iota. Therefore, it can be written as 3 plus 4 iota plus 2 plus 8 iota, right? So, it can be written as 5 plus 12 iota mod whole square. That is, lambda is greater than or equal to half into, this will be equal to 169, right? That is, 2 lambda should be greater than or equal to 169. Now here the least value of 2 lambda should be 169, but in the question it is given that lambda is belonging to n, that is a natural number. Therefore the least value of 2 lambda will be 170, right? So the correct answer will be option number 4. Next is question number 67, which says that 5 letters and 5 envelopes are numbered 1, 2, 3, 4 and 5, and letters are to be placed in envelopes so that each envelope contains exactly one letter and no letter is placed in the envelope bearing the same number, and moreover the letter numbered 2 is always placed in envelope numbered 1. Then the total number of ways in which it can be done is, let us say we have 5 letters here, that is 1, 2, 3, 4 and 5. And we have 5 envelopes, that is 1, 2, 3, 4 and 5, right? Now, we have to do derangement here, that is, letter number 1 cannot go into envelope number 1, but it can go in any other, right? If I don't talk about this condition right now, then this question is simply a derangement of 5 letters into 5 envelopes, right? So, what is the formula for that? We know that it will be equal to 5 factorial into 1 minus 1 upon 1 factorial plus 1 upon 2 factorial minus 1 upon 3 factorial plus 1 upon 4 factorial minus 1 upon 5 factorial, right? This is the number of ways of deranging 5 letters. So this will be equal to 44. Now here it is given that letter numbered 2 is always placed in envelope numbered 1, right? Now let us say this is the event E, right? Now in event E, what we have done is letter 2 is going in either 1 or 3 or 4 or 5. Because it is not going in 2 because we are doing derangement, so it cannot go in the same numbered envelope, right? अब ये जो E event में हमने निकाला है आंसर, in this 2 can go in these 4 envelopes, but according to the condition given in the question, it is given that it is going in envelope number 1, right? So if I divide these cases upon 4, then we can find the number of ways for the required event, right? So this will directly be equal to 11, right? So the correct answer is option number 4. Next is question number 68, which says that if alpha, beta and gamma are the real roots of the cubic equation, x cube minus 12x plus 5 equal to 0, then the value of GIF of alpha plus GIF of beta plus GIF of gamma upon fractional part of alpha plus fractional part of beta plus fractional part of gamma is, right? Now here, as alpha, beta, gamma are the real roots of this equation, hence sum of the roots, that is alpha plus beta plus gamma, is equal to 0, right? Now alpha can be written as GIF of alpha plus fractional part of alpha. Similarly, we can write beta as GIF of beta plus fractional part of beta plus GIF of gamma plus fractional part of gamma equal to 0. Now, this can further be written as GIF of alpha plus GIF of beta plus GIF of gamma can be written equal to minus of fractional part of alpha minus fractional part of beta minus fractional part of gamma. That is the value of the required expression, that is GIF of alpha plus GIF of beta plus GIF of gamma upon fractional part of alpha plus fractional part of beta plus fractional part of gamma will be equal to minus 1. Hence, the correct answer will be option number 2. Next is question number 69, which says that the number of ways in which all the letters of the word extension can be arranged such that no two E's and no two N's come together. Right? So, the number of ways will be equal to N1 minus N2, where N1 is equal to number of ways of arranging the letters of the word extension in which no two E's come together. And let us say N2 be equal to number of ways in which no two E's come together but two N's are together. Right? If I subtract N2 from N1, then we will get the required number of ways. Now, N1 will be equal to, let us firstly arrange the letters of the word extension, that is, we have E, E, N, N and X, T, S, I, O. Now, to find N1, we have to find the number of ways in which no two E's come together. So, leaving these two, let us arrange the rest of the letters. That is, we will arrange these 7 letters in 7 factorial upon 2 factorial ways. Right? Now, in between we have 8 gaps. So, let us select 2 seats from these 8 gaps in 8 C2 ways. Right? So, this will be equal to 70560. Similarly, finding the value of N2 in which we want the two N's to be together but no two E's should be together. So, taking N as 1, we will arrange 6 letters here in 6 factorial ways. In 2, as no two E's should be together, so we have 7 gaps here. So, from 7 gaps, we select any 2 gaps. So, that will be equal to 15120. So, the required number of ways will be equal to 70560 minus 15120, which will be equal to 55440. That is, the correct answer will be option number 2. Next is question number 70, which says that the maximum number of points of intersection of 5 distinct parabolas in a plane is, let us say this is the coordinate axis. So, we will see that what are the maximum number of points of intersection of any 2 distinct parabolas. Let us say this is one parabola here and this is the other parabola. So, the maximum number of points of intersection of 2 parabolas will be equal to 4. Right? Now, the required number of points of intersection will be equal to 4 into 5C2. Because in 5C2 ways, we can select any 2 parabolas from the 5 parabolas given. So, this will be equal to 10 into 4, that is 40. So, the correct answer will be option number 3.